Today we'll gain a broad overview of NiftyNet, a deep learning framework designed for medical image analysis. NiftyNet will get us up and running quickly on our deep learning experiments by leveraging a large library of pre-written code useful at every stage of the deep learning pipeline. This talk focuses on the high-level background knowledge, and in subsequent videos we'll go into the details of using NiftyNet. Our objectives are as follows: introduce NiftyNet and explain why deep learning frameworks are useful. Understand that a deep learning experiment in NiftyNet can be fully specified by a NiftyNet application and a configuration file. And we'll take a first look at the NiftyNet model zoo and understand that we have convenient access to shared trained or untrained networks hosted on the server. As a reminder, here's our general workflow during a machine learning experiment. Once we've decided the clinical task of interest and collected and labeled our data, NiftyNet will help us execute the model development and evaluation stage. At the end, our goal is something of this sort: inputting an image and outputting some clinically valuable information. In this illustrative case, a segmentation of the necrotic core, enhancing tissue, and edema in a glioblastoma. So what exactly is NiftyNet? NiftyNet is a software framework which, loosely speaking, is a large library of reusable code modules that provide a particular function. In this case, functions that will be of use to us include data input and preprocessing, defining our deep learning network, generating meaningful network output, and evaluating the performance of our model. Such modules speed up our deep learning experiments, as we save a lot of time by not writing our own code and reinventing the wheel. For more advanced uses, we can extend the framework by writing custom code, but this is a topic for later discussion. Now, NiftyNet is a framework built on top of another deep learning framework created by Google called Tensorflow. And at an even lower level, most of Tensorflow is built using a programming language called Python. Now, just like we don't need to know the inner workings of a car to drive one, we can use NiftyNet without being experts at Tensorflow and Python. However, some knowledge will be useful in more advanced cases and in troubleshooting, and help us prevent a trip to the metaphorical mechanic. Now, what kind of things can we do with NiftyNet? NiftyNet allows us to execute each stage of the deep learning workflow, that is, training, inference, and evaluation of our model performance. With NiftyNet, the details of this entire workflow can be specified by two objects: an application and a configuration file. Loosely speaking, an application contains the code for what we're trying to do, for example, classify an image, and the individual steps to get there, while a configuration file specifies how we're going to do it, with specific instructions at each step. First, let's discuss the application. At this point, a NiftyNet application can be thought of as a box which contains all of the components necessary to execute every step of a particular deep learning task. The components include a data reader to load data from files such as DICOM or NIFTY files, a sampler to generate data samples to feed into our network, the network itself, and an output handler, which serves multiple purposes depending on whether we are training or testing the model. NiftyNet has multiple applications, each of which specifies a particular task. For example, there are separate applications for segmentation, classification, or regression tasks, among others. You can explore more of these tasks in the NiftyNet documentation. Now on to the configuration file. The configuration file can be conceptualized as a blueprint which specifies the details of the individual components within the application. Let's break this down further. Every configuration file is composed of several sections. For instance, here we see sections specifying input data parameters, system parameters, the network, and so on. Within each section, there are several name-value pairs, which further specify particular parameters. Let's take a look at an actual configuration file, for example. Here, we see under the Input Configuration section several subsections pertaining to data of different MRI weightings, as well as the ground truth labels. Under each section, we see several name-value pairs. For instance, the file path that the application should follow to obtain the data, as well as how each MRI volume should be resampled so that each MRI volume has a consistent dimension with respect to one another. In the network section, we see some name-value pairs specifying certain hyperparameters of our network, including what activation function to use, the type of regularization, and batch size. We can modify the components of every section to suit the particular needs of our experiment, if the default settings are not appropriate. In this way, we can efficiently make changes to every step in the deep learning workflow without the need for rewriting code. take some time to explore the configuration file documentation on the NiftyNet page. Now let's say we initially didn't know how we wanted to build our network and set the experiment's parameters. We would instead like to use a pre-built model and see how it performs in our data, perhaps tweaking it later. The NiftyNet Model Zoo serves this purpose. The Model Zoo provides convenient access to shared trained or untrained networks hosted on a server. We'll learn how to obtain these models in a later video. Here's a screen capture of the Model Zoo page. If we want to segment organs within the abdomen, for instance, we could explore this model and read some of the instructions on how to obtain it, as well as a link to the literature from which this model was created. Now, with a grasp of the big picture of NiftyNet, the application, and configuration file to specify our deep learning experiments, we can move on to applying this knowledge to some real-world examples. We'll do so in the next set of videos. In summary, we've been introduced to NiftyNet and understand why deep learning frameworks are useful. We've learned that a deep learning experiment in NiftyNet can be fully specified by a NiftyNet application and a configuration file. Finally, we understand that we have convenient access to shared trained or untrained networks hosted on the NiftyNet Model Zoo server.